In this video, we are going to be talking about solving linear equations. So a little bit of stuff before we do that. It says, when solving, make sure to preserve the basic principle of equality, which basically means whatever you're going to do to one side, you also have to do to the other side. If you add 5 on one side, you got to add 5 on the other side. If you divide by 2 on one side, you got to divide by 2 on the other side. That's what keeps everything equal. Okay, so you're just manipulating the equation, but you're still keeping both sides technically equal to each other. All right, so how do we go about doing that? How do we know when we're done? We are going to isolate the variable. That's our goal. We're going to get everything, we're going to get that variable by itself, everything else to the other side. Okay, that will be the solution. And then we'll double check that to make sure it works, that it satisfies the equation. So you got some fancy names, the addition axiom, which basically means whatever you're going to add or subtract on one side, you got to do it to the other side as well. And then there's going to be a multiplying and dividing one as well. So what you'll hear a lot from me is the description of undoing. We're going to undo to isolate. Okay, whatever the variable is. Could be x, could be whatever. But right here, right now, that 4 is being added to the x, so we want to undo the addition of 4. To do that, we are going to subtract 4. But whatever we do to the left side of the equation, we're also going to do to the right side of the equation. So what it does is this addition of 4, when we subtract 4, it removes it as if it's not there anymore. So we moved it to the other side. Okay, is another way that you'll hear me describe it. So if we're going to move that addition to the other side, we have to do that with subtraction. That gets us an x all by itself. And then 9 minus the 4 would equal 5. Okay, so that's basically our goal from problem to problem to problem. So right here, we have a subtraction of 2. We want to undo that by adding 2 to both sides. So then here, x is going to be by itself. Those 2 will undo each other. And then you have equals to 6. So just to make sure that we're right, if we go back to the original was something minus 2 is supposed to equal 4. That something would be 6. 6 minus 2 does equal 4. Over here, it was supposed to be something plus 4 equals 9. That something is 5. Okay. And then over here, they just kind of try to mess with the order a little bit. That's okay. This is a positive 5, so we want to undo it with a negative 5, aka subtracting 5 to the other side. That gets the 5s to cancel. And 2 minus 5 or 2 plus a negative 5 would equal a negative 3. Okay, and then if we plug that back in, 5 plus a negative 3, you would have 2 more positives than negatives if you added those 2 together. Then over here, again, kind of the order gets shifted around a little bit. That's okay. We're still subtracting 1 from x, so to undo that, we'll add 1 to the other side. That adds up to 11. So our x is equal to 11. Okay. So when you have a multiplication thing, so again, there's a fancy multiplication axiom. It basically means multiplying or dividing. It's not an of, that's an or dividing. So multiplying or dividing, whatever you're going to do to one side, you're going to do to the other side as well. So if you needed to multiply both sides by something, or if you need to multiply one side, you have to multiply the other side. If you need to divide one side, you have to divide the other side. That's all that really is talking about. So right here, again, we're talking about undoing. So right now, 4 is being multiplied to x, and I want to undo that. So to undo the multiplication of 4, I will divide both sides by 4. Whenever I'm doing to the left, I'm doing to the right. So the 4 that's multiplying by x that's also being divided would undo each other, cancel each other away. And then x would equal 48 divided by 4 is 12. So 4 times 12 should equal our 48. And then over here, again, doesn't matter if the order gets switched around. This is still multiplication between the 2, and I want to divide that. So, So I want to divide by 0.5 to both sides. Divide by 0.5 to both sides. And so if I take 45 divided by 0.5, I actually get more. So x equals 90. All right, and hopefully the logic makes sense when you kind of plug it back in here, because 0.5 is a half and you're doing multiplication. So you're taking half of something should equal 45, half of 90 should equal 45. Okay, now here, what this is technically it's a negative and it's multiplying to the x. It's really a -1 that's multiplied to the x. So we can get rid of that by undoing it with division of -1 on both sides. And so the negative and the negative cancel each other to a positive. The ones just kind of go away. And then 25 divided by -1 is a -25. All right. All right, so they get a little bit bigger. All right, so you are solving equations with like terms on the same side of the equation. So I kind of describe this as we need to clean up some stuff. We can make these look like these. It's kind of what we got going on. So we're going to combine some like terms and then see where we got to go from there. So right now we have a 4x minus a 1x, which is 3x. Right, 4 minus 1 is 3. The x doesn't change. The x is what allows you to put the other numbers together. And then on the other side, these are like terms as well. So that can add up to 15. And now they look just like the other problems. We're going to undo multiplication of 3 with division. And so our x would equal 5. Okay, and we'll do this one time to check to make sure that it actually works. So if I take that 5 and I plug it back in, I would have 4 times 5 is what that tells me, minus 5. Supposed to equal 7 plus 8, which we already know that that's 15. So I'm double checking that this side adds up to the same as what this side adds up to. So that's 20 minus 5, and that does in fact add up to what it's supposed to. Okay. So here we have some like terms. I have a 6x minus a 10x. I personally add the opposite. So I have more negatives than positives by 4. So I have a -4x. Here I have more negatives than positives by 20. Okay, so that's me cleaning it up, combining my like terms. And then now I have multiplication that I still need to get rid of with the division of a -4 on both sides. So that way those two can cancel each other. And we're left with a negative divided by a negative, which is a positive. 20 divided by 4 is 5. Same answer. And then again, you can plug it back in to make sure that it actually works. All right. Same idea, except this time your like terms are not on the same side. So it's nice when they're on the same side, but that doesn't mean we can't make that happen. So if we have like terms, we need to put them together. So that means we need to take one and move it to the other side. Okay, so I'm going to take the 4x on the left and move it over to the right. I could take the 8x and move it over to the left, but I also have a value that doesn't have a variable, and that's not a like term. So I'm going to take things, and I'm going to leave the 9 here and move the 4x to the right. So since that's a subtraction, I need to undo it with addition. So I'm going to be adding 4x to both sides, so it cancels on that side. So I have a 9 equals, let's add a 12x. All right, and now I need to undo my multiplication with division. And the 12s go away, and then I just have to simplify my fraction. So if I simplify my fraction, a 3 can go into both, so that's a 3, and that'll be a 4, so 3/4. Okay. Same idea here is the 9 and the 15 are like terms, and so I'm going to take that 9 and bring it over to the other side with subtraction. And so that would go away. I'd have the 3x by itself on the left-hand side of the equation. On the right-hand side of the equation, I got a 15 minus a 9, which is 6. And then I want to undo multiplication with division. We'll divide by 3. X equals 2. Okay. So I forgot to mention, let's just kind of, what are our steps? What is our process? The first thing that I always look to do, which doesn't exist on every problem, none of these exist on every single problem, but if you have parentheses, you're going to need to distribute. Okay, get rid of parentheses. We haven't had that yet, but it's coming. Okay, the second thing that I'm going to look to do is combine like terms. combining like terms means you may have to move things from one side to another, which is exactly what we're doing. We have like terms, we need to put them together. We had like terms, we need to put them together. Okay, and then the third thing is typically the last thing that you have to do is take care of any multiplication or division stuff. Multiply or divide. That's kind of your process. Get rid of parentheses, combine like terms, I kind of clean up, and then typically you'll have some sort of a multiplication or division that you'll have to do to finish it. Okay, so parentheses, I don't have it, but I do have like terms. So I want to put those x's together and I want to put those 3's together. So I'm going to take this 3x and subtract it over to this side. It keeps the x positive. Otherwise, I'd subtract a 4x and getting a negative over here. I'm going to just try to keep it maybe a little simpler for myself. So I'm going to subtract that 3x over to this side. Okay, so 4x minus 3x is 1x. And then I'm going to drop down where what else I haven't worked on yet. So I haven't done anything with the minus 3 here. Try that again. These are gone, so just a minus 3 on this side. Okay, and then I'm going to still have like terms, so I'm going to take that 3 and bump it over to the other side by adding it. So that goes away. That actually goes away, and so that value is 0. And so we get an answer of 0. Okay, so I have a couple steps that I got to take care of here. I have some like terms on the same side, so let me do that first. So I have a 2x and a 5x makes 7x. And I haven't done anything else. So let me bring down this, let me bring down the 8 and the minus 6x. So that's first step is I have like terms on the same side. Let's put them together. I'm going to put the x's together. I could take that 7x and subtract it over, but now I have some negatives going on. I'd rather take that 6x and add it over to the other side. Wonderful. And then that puts us at a 13x. Drop down the minus 3, drop down the 8. And then here I'm going to add the 3 over to the other side, still combining like terms. So we had a lot of like terms to put together. So those go away. 13x equals 11. Okay, now I'm finally, so I've combined all the like terms I can. I put those two x's together. Then I had x's on the different sides that I needed to put together. So I brought that one over to here. So my x's are on the left. Let's put my constants over to the right. So moving that one over to that side. And then I'm left with 13 that I need to get rid of. So I'm going to divide by 13. So x is going to equal 11/13. Okay, so really not much else can happen to these other than if you have parentheses. If you have parentheses, then you'll have to do distribution, and then it's going to look just like that or similar to it. Okay, so you're going to see that on the next one. All right, so parentheses. Here's the thing that people mess up on. That is actually a -3 that you're distributing in, not a +3. The sign is included when you distribute that in. So that whole thing is being distributed in. So I have a 28 equals a 7x. -3 times x is a -3x. -3 times a -4 is a +12. Okay, and then I'll combine my like terms. I have a 7x minus a 3x, so that's a 4x. I didn't do anything with the 28. I didn't do anything with the 12. 12 and 28 are like terms, so since my x is on the right, I'm going to take the 12 over to the left. So that's 4x. 28 minus 12 is 16. Okay, so I took care of my distribution. Took care of my combining my like terms, and as always I have my last thing is to get rid of multiplication. So we'll divide the 4 over to the other side. That goes away, so x equals 16 divided by 4, which is 4. And the last thing here, last problem of this is I have a distribution, and if you need to, it's really a 1 that's right there. There's always something there, so it's a -1 that I'm distributing in. All right, So I have a 6, a negative 1 times x is a negative x, negative 1 times 3 is a negative 3, and that equals the 2x on the other side. If I have like terms, I like to keep things positive, so I'm going to add the x over to the other side, keeping things positive. And then I have a 6, so that goes away. 6 minus 3 on the left-hand side, and 2x plus 1x is 3x on the right side. So this is 3 equals 3x. Okay, so I took care of my distribution, took care of my like terms, and then my last thing is I want to divide that 3 over the other side. So x is going to equal 1. All right, the last thing is a word problem. So we have a machine part weighs 2.7 kilograms and is to be shipped in a carton weighing X grams. If the total weight of the 3 packaged material parts is that, how much does each carton weigh? All right, so we have 3 packaged machine parts. Okay, so there's 3 of these. So this machine part weighs this, 2.7, but it's in a carton, and the carton doesn't weigh nothing, so there's weight to that, but we don't know what it is. Okay, so together, that's how much each package weighs with the carton and the part. But there's 3 of them, and together, they make 9.3 kilograms. So how much does each carton weigh? So there's how much the part weighs. We don't know how much the carton weighs. We're going to solve. So we get rid of parentheses with distribution. So 3 times 2.7 is 8.1. 3 times x is 3x. And then that equals 9.3. And then I'm going to solve like normal. I'm going to bring my like terms together by subtracting the 8.1 to the other side. So I have a 3x equals 9.3 minus 8.1 is 1.2. Divide by 3. X equals 0.4. So that should be 0.4 kilograms. So that's how much each carton weighs. So together, if you added those together, they were each weighing together 3.1. And if you had 3.1 times 3, you get your total weight of 9.3. All right, that was solving equations involving all sorts of different things with combining like terms, distributions, multiplying, adding, subtracting, dividing. Thanks.